Hi, everyone. Thank you for joining Kubernetes in the government. 5 key requirements for your app modernization journey. Next. I am Mike Wood. I am the Regional Vice President of Public Sector at Spectro. Today with me is Tommy Scherer, who is our Principal Solutions Architect.
Good morning.
Today we're going to talk about 5 topics we hear most often in the government space. We'll discuss the challenges a lot of agencies face and where they're trying to get to as they move to their modernization goals and their DevSecOps. Most agencies we engage with agree that the advantages to moving to containers and Kubernetes is powerful. The challenge is how do they do it and how do they do it in a way that is less daunting. Next slide. So if we look at scaling for simplicity, how can you scale to thousands of clusters across different environments without creating a management and performance nightmare? Next. So if we look at Kubernetes and the cloud native ecosystem, it's really a new shift from the cloud business model that is the promise of the OS of everywhere, right? Over the connecting thread. However, while the Kubernetes promise is great, it is not easy for production at scale. Why is this? Well, on one hand, as teams operationalize Kubernetes and transition ownership from different teams like developers to IT, operations, and platform engineering, they're forced to choose between a risky do-it-yourself approach to Kubernetes or an opinionated model, where commercial platforms are limited options and the tools provided by those individual vendors. We're also seeing a huge escalation in the usage of multiple Kubernetes distributions and the integrations that go along with them, which means teams need to maintain multiple platforms. And how do we do this within this kind of ecosystem? What we have noticed is that we have moved from the era of debating on which distribution of Kubernetes is better to an era of being free to choose the flavor of the stack that each individual person needs the most. And we'll cover that a bit later. We have commissioned a report last year on the state of Kubernetes, and we found that most of our customers, 33% of the organizations that use Kubernetes, have more than 5 integrations, and 75% of those facing challenges of interruptibility in their entire stack. We've also seen that 69% are deploying these Kubernetes clusters to multiple locations, with 14% of those using 5 or more locations. This approach also requires multiple tools to be cobbled together, and diverse skills are required to manage the life cycles of Kubernetes environments. Ultimately, all this results in increased costs while also providing slower application innovation. Next slide. So if we look at flexibility and openness, can you drive a modernization strategy that's right for your organization without being locked into a specific vendor? So there are really 2 key requirements that we're hearing from a lot of our customers. They want an architecture that's built for scale and one that's separating the management plane from the control plane. They want repeatability and a declarative management style. And the industry has validated this by instituting CAPI or cluster API. Otherwise, how can you manage all of those stacks and avoid this configuration drift? Next.
So Mike touched on a lot of really great points, and looking at the CNCF landscape can really look daunting. If you look at the landscape, there's going to be a huge variation between the technical readiness level. There's projects that have just begun that have a few contributors to ones that have major backing from large contributors, open source communities. What we've done at Spectro Cloud is taking a look at the CNCF landscape and really looked at the projects that are most ready for production. So we take the best of breed from the networking, from ingress controllers, from service mesh, to databases, to build these pieces that we call packs. We then build clusters out of these packs, and think of a pack as a curated Helm chart or manifest that makes it much easier to deploy. And then it can also make the pack specific for different infrastructure. Because we're finding a lot of our clients have requirements to deploy on the tactical edge, in the data center, and in the public cloud. And a lot of that driver to that deployment is cost, availability, and time to provision. So what we've done is scaled this down and allowed you to run any of these add-ons on that common currency of Kubernetes, because we feel that's the only way to support your application and that payload of data from the edge to the data center, into all the public clouds.
So we look at this ecosystem. Sorry, can you go back one screen? Yeah, if we look at this ecosystem, it's really about Kubernetes and cloud in the cloud native ecosystem. There are hundreds of these projects and applications that teams need to leverage and build applications on top of Kubernetes, as Tommy was referencing. And we are hearing clearly from customers that they need to have flexibility over the choices of those integrations and not be told and pre-described what's the actual stack that they're going to be using. So if we look at applications and developer innovation, how can you support your applications teams with the infrastructures they need without losing control? Next.
And this is a great point, is, how do you allow those developers to grab those innovative projects from the CNCF and then build a common platform with guardrails?
So if we take a step back and we look at Kubernetes option as a balancing sheet, right? Of how do you develop with speed and application development while also control with your corporate IT and still maintain the environment that you're trying to your desired state, right? And if we ask ChatGPT what they think about why having developers manage Kubernetes is such a bad idea, it'll give us a list of 5 really specific things as to why they shouldn't do that. Lack of experience, just having time to actually work with this new technology, or having the time to learn the nuances of any particular Kubernetes distribution. The complexity, as we saw on the cloud native screen, there's hundreds of integrations. How do you manage the complexity of integrating different applications across the entire stack? Distraction from the core responsibility that is their normal job, and how do they find time to do learning and consuming new technologies? And then if you look at increased operational overhead, increasing management and resource consumption, that can be a killer for any organization. And finally, if you look at integration with existing structure, not only are you looking at integration within the cloud native space, but you're also looking at hardware and, as Tommy mentioned, tactical edge applications. So if we look into next, we can talk about securing the stack and protecting the edge. Tommy?
And I think, there's a lot of tools to secure the stack within the data center. If you follow the 5 pillars of zero trust, you can use two-factor authentication. You can use technologies to do mutual TLS encryption. You can build a platform on top of FIPS 140-2. But the rules really change when you start deploying actual edge devices in the field. So how do you take those same pillars of zero trust and allow that edge device to leave the safety of the 4 walls of a data center? So we've worked very closely with Intel to develop and build a standard. Is how do we secure the Kubernetes stack, all the way from that hardware device all the way up. So what we've done is built on top of the secure edge native architecture, which allows us to take an edge device and leverage things like trusted compute modules, TPMs, and give the device an authority to boot. So if someone adds a USB device, changes hardware, the device leaves the network, that device physically won't boot. The actual data, on the device is encrypted at rest. And then once the device comes up, is unlocked from that TPM, we can then pass in an encryption key to decrypt that data. And at that point, we can then start to run Kubernetes in those containers. One of those containers could be a tool to enforce policy. So you could use something like an open policy agent or a Kyverno to actually enforce, whether the hardware is secure, whether the device is unlocked, whether it's on the proper network, if this device, has been blacklisted before we actually continue to boot the device and run applications. So in the case of a tactical edge where a device might end up in an adversary's hands, all they have is a piece of silicon. They can't get encryption keys, they can't get data. And that's the idea of securing the platform all the way from policy running from within Kubernetes all the way down to the silicon that is built by Intel.
Great. Let's get into a demo.
Perfect. So if we go to the UI of Palette Vertex, and this is a platform that was developed on the commercial side, been shipping for 5 years, and then we took it and we built it specifically for the government. We rebuilt a lot of the CNCF add-ons to be used with FIPS 140-2 ciphers. We provide operating systems that are built on a hardened and stigged version of Ubuntu, which includes Ubuntu Pro licensing to enable FIPS. We then took a peer upstream Kubernetes flavor. We used to give it away for free. It didn't have a name. Gartner made us name it. It's called Palette Extended Kubernetes. Then we also have the ability to run something like an RKE2, which is FIPS validated. We really don't have an opinion on what flavor of Kubernetes you seek to run. We feel the flavors that leverage cluster API are beneficial because it allows for ease of upgrades, ease of scaling, but we can bring in clusters into the environment that might be built with more older techniques, things like Ansible and Terraform. All we need is that common currency of Kubernetes to be able to bring that into a true management plane. And that's a differentiator of what Palette Vertex really is it's not a control plane. And what we've done is uniquely built this for scale, is isolated that management plane from the control plane to allow us to manage thousands of clusters versus in a traditional cluster API view, you're typically only going to be able to manage, maybe 50 clusters before you have to build a new separate enclave and a new control plane.
And honestly, what we're seeing with most of our customers is they have kind of got into a groove of, I'm using this type of Kubernetes distribution, but I want to move to something else. And that seems like a daunting task and it's really complex. I don't have the time or the resources to do that. This is where Vertex comes in, where you can move and shift as markets change or outside forces dictate into different Kubernetes distributions and the entire stack as needed with little to no downtime. Tommy?
And that's a really good point, is we've seen, kind of early within the Kubernetes community, leveraging things like managed Kubernetes, things like AKS from Azure, EKS from Amazon, and then leveraging a lot of those tools and projects and products within those cloud providers. They give them cute names like Elastic Beanstalk, so they feel like an open source project, but they keep you very much tied to that infrastructure. So what we've done is leverage those CNCF tools to decouple the actual Kubernetes and a lot of those services from the service provider to allow that freedom of mobility. So you might find that as contracts with companies like Oracle or Azure or Google, it might be more cost effective, or you might have access to additional bandwidth by moving these workloads in other clouds. But if you're tied to that infrastructure, to that managed Kubernetes distribution, how do you migrate those workloads without a true management plane? And one of those lenses that we give you is to look at consumption of the cloud, look at cores, and what those costs are. So you can use this very much for public cloud, which is very easy to figure out what they charge you. They publish their price lists and they charge on a monthly basis. But you can also plug in cost analysis for your on-premise infrastructure. So if you know roughly what a server costs and you divide that up into a CPU core, gig of RAM, gig of storage, you can contrast those workload costs between public cloud and on-prem. You might find that your hard-hitting applications, your databases, your AI/ML workloads might make more sense to run on-premise because you're able to run those workloads closer to 100%, where your lighter, more transient workloads, maybe web apps that you need for availability might make more sense in public cloud. And giving you those tools to deploy applications wherever it makes sense for the teams and the mission. We drive a lot of these CNCF add-ons, and our value add comes from our cluster profiles. So we have a couple of cluster profiles within here. One is for AWS, one is for vSphere environment. And what we can see is they're going to support the application upper layers in the exact same way. What's different between AWS and your on-prem infrastructure is going to be, mostly around what you leverage from storage and what you leverage for a load balancer. So in the world of vSphere, you can leverage, things like Avi load balancers, F5. If there's not a load balancer within the environment, we can leverage something like a metal LB. And then for storage, we can very tightly integrate with the storage that's built in with vSphere, or we can bring in, different CSI layers. We could bring in pieces like a Portworx, a Longhorn, a Rook Ceph if you need, block file and object. So giving you a lot of flexibility to store the data however it needs to be, depending on, if you need to store large files, if you need high throughput. And if we contrast this cluster profile with one designed for AWS, we're going to see that we're running basically the same OS image. We're running Ubuntu. We've swapped out the storage though. So now we're leveraging the elastic block storage within AWS, but we're supporting the application the exact same way. And we seek to build these cluster profiles the same way for lightweight edge devices. So we truly have the ability to treat an edge device exactly like the cloud. So we built an open source project that we gave back to the community called Kairos. It's a wrapper around whatever operating system you want to bring to run on that edge device. Could be SUSE, could be Ubuntu, could be RHEL. And then we build that operating system much like a container. We build it in layers. And this allows us to do a multitude of things. One, we can store the updates to these devices in something like an OCI registry, like an ECR with an Amazon or a Harbor registry. And it also allows us to deliver very small changes. So you might be keeping the operating system the same, but you might be swapping in a new version of Kubernetes or a couple of stacks up here. So if an image is 1 to 2 gig, you may only be sending 1 to 200 megabytes when you actually look to update the device. We also have the ability to have multiple partitions on the device to allow us to upgrade in place. What we're really calling this is over-the-air updates, but plus. And that plus is if we're just reloading, a couple of these packs, we can do it many times without a reboot. Bringing more heavy updates like a new STIG'd operating system is going to take a reboot of the device. But we also have safeguards in place with the device. If it doesn't boot and it doesn't pass its liveliness check, it'll reboot itself and it'll go into the good known last running configuration. So in the case of you touch the device once, you image it, comes up with a QR code, you bring that into the platform, and then you can allocate it as either a single node. We also have the unique ability to do high availability in 2 nodes, or you can build traditional Kubernetes clusters with isolated control plane and workers. And that's all done through driving these cluster profiles.
So that 2-minute reconciliation loop is important because as we get into edge devices and potentially contested areas, if you have a device that gets into the wrong hands, that'll automatically either reboot to the last known image, as you said, or it will not connect back to the network if it's not authenticated back to call it the mothership. Also, this is the stack that we referenced as far as using CAPI. So cluster API is injected from the operating system at the bottom of the stack throughout the stack all the way up to the application level layer. So we're able to manage the entire cluster using cluster API, which gives us those rapid deployments and rapid updates that Tommy was talking about. Also, Tommy, if you can go back to the API, it's not just a drop-down, click-through type of platform. If you are a Kubernetes person and you have a lot of knowledge and you need to make certain changes and configurations based on an environment or use case, you can get into the API. We don't hide the code. You are able to get in and make command line type changes while also doing click drops if that's kind of your use case.
And that's a great point. So the idea is to integrate with whatever tech stack you have. So if you have users that enjoy using a UI, it's available. If you want to use our API natively, we have a Swagger file. It's well documented. If you want to use the CLI, we have a curated CLI that allows you to do a lot of these same things. And we also have a Terraform provider. So I was at a different Kubernetes company and we're adamantly opposed to Terraform. And we used to have almost religious debates on it. And what we've done at Spectro Cloud is actually developed a Terraform provider for cluster API. To date, it has something like 4.4 million downloads. So it allows you to fit within your structure of infrastructure as code. And Mike touched on this earlier, that if you have current ATOs for a specific operating system or a specific flavor of Kubernetes, continue to use that by all means. We'll give you tools to move off that platform if you need to, but by all means, the goal is to get these into production, support the mission as quick as possible. And a lot of the spots within the UI, you can do your entire task, and then you can actually go to the API, and this will give you that API payload. So if you truly want to build a platform and work towards the gold standard of a continuous ATO and leverage infrastructure as code, this is one of the tools to do it. So our goal is to not build snowflakes, is to build these clusters in a very curated way and be able to document that and make it very reproducible. The other thing about these cluster profiles is it allows you to also export them. So in environments where you're deploying clusters across multiple domains and multiple impact levels, we give you the tools to take one of these cluster profiles that might be built within a connected environment on the low side, and where you can have a great deal of collaboration with developers, very easy to bring them in, and they can build one of these curated stacks, and then you can export the profile. And exporting the profile, it's just a payload of JSON. And all we have to do is take this payload of JSON, 77 kilobytes, and then the artifacts, which we prepackage for you to the high side network. So those artifacts are a combination of Helm charts and the actual container images. We give you tools to import those into an OCI registry that's available within that impact level. And then it allows you to build these clusters the exact same way. So that the application that you developed on the low side in a connected environment is going to run the exact same way in a fully air-gapped, high impact level environment. So again, it's taking that ability to make these clusters very reproducible with both the combination of APIs and cluster profiles.
Great. Do we want to get into virtual machine orchestration, or do we want to get into cost analysis?
Sure. So one of the pieces that we can bring to the platform is virtual machine orchestration. VMO is built on top of libvirt, which was the foundation for OpenStack. So technology that's been around for about 10 years, has some very large contributors, and now they've brought it to the Kubernetes world, and they called it KubeVirt. But it's very much a CLI-based tool, a little rough around the edges. So we built a platform called Virtual Machine Orchestrator, and this allows you to do a lot of the tasks that you would expect from a virtualization platform. That ability to add multiple interfaces, that ability to add additional disks, support live migration. So by no means a full replacement for a VMware environment, but it works really well for organizations that are looking to transition towards containers, but still have a handful of applications that require virtual machines. We're also seeing a great deal of demand for virtual machines on edge devices. There's a lot of software that's distributed by vendors is still in the form of a virtual machine. And we can bring, some of those pillars of zero trust into that virtual machine world. So we can run things like a sidecar, do mutual TLS. You'd leverage something like an Istio service mesh. We can run it on an isolated network. So within Kubernetes, we can run an overlay network that allows the pods to communicate with each other, but not necessarily the outside world. You'd have to expose a pod either by service type load balancer or ingress. And then it also produces an artifact. The virtual machines are orchestrated much like a container. They have a declarative YAML. So you can begin to deploy and manage the lifecycle of virtual machines from a DevSecOps pipeline. So you could actually deploy these virtual machines from something like a GitLab or a harness. So allowing legacy virtual machines to move into this more modern cloud native world and really work towards that continuous modernization.
Great. Often we get asked about submitting documentation and reports to security officers for logging, for who's done what, who has access to what. Can you touch on that?
Absolutely. So very tightly integrated to the platform is audit logging. We have an interface to view this. You can also pull it from API. You can also push this to a centralized logging system like an AWS CloudTrail or a Splunk. But what it's going to document is what was done to the platform and how it was done, whether they came in by the API, UI. You can filter this. So you can see, that your users are coming in, they're being good citizens. And if there was a change, made to a cluster, you can see, when that change was made. And a lot of times when you actually drive a change within a cluster profile, it's going to actually give you a diff screen. It's going to show you what was changed. And then many times there'll be comments of why it changed. We also leverage the ability within these cluster profiles to version. So that very, very quickly allows you to roll a new update through development, staging, and production. But most importantly, allows you to very rapidly roll back. So if you do find an issue that you didn't find in testing that might actually hurt staging or production, you can very quickly roll back those changes, and those will all be documented within the audit logs. Also, built into the cluster is the ability to do scans. So we have Kubernetes configuration security. So this is leveraging a tool called Kubebench. This is looking at things like open ports. It's looking to see if people are bringing containers that have the ability to escalate privilege or run as root. We also have another project within the platform called KubePen. This does a fairly long penetration test on a Kubernetes cluster to see if there's any vulnerabilities or open ports. And then we use another tool called SonoBui for Kubernetes conformance testing. So this is making sure that you're setting things like limits for CPU and memory. What that allows you to do is ensure that you're not going to have containers using too many of the resources. Is really the goal with Kubernetes is to be more efficient, leverage tools from cluster API to automatically scale. As you see pressure from the applications, add additional nodes. But the idea is that you want to run these clusters at 80 or 90% capacity, then only add additional compute when you absolutely need it. And one of those ways that we can keep that in check is by enforcing quotas, limits, ranges, and then also ensuring that we have limits set for our actual applications. So if a piece of code has a memory leak, it's not going to spin up additional infrastructure and incur additional cost.
Great. Before we continue, we do have a question, Tommy. What about edge remote deployment?
So edge remote deployments is we actually build an artifact. It's edge installer ISO. What that allows us to do is touch the device a single time. So that could be physically with a USB device, or if the device has something like an IPMI or an ILO or an iDRAC, you can do it over the air. That's the last time you actually have to touch the device. It boots into the operating system. You get a QR code. Optionally, you can pre-pack that image with a join token. That token will communicate with the API of the management cluster, and then bring it in as an edge host. Once it's within the platform as an edge host, you can choose to add additional nodes to it to make it a multi-node Kubernetes cluster. It could just be a single device. But from that point, you're just deploying payloads of software to it, so a curated profile on that device. And at that point, as long as there's a repository that device could touch, so a local repository either running on the device or within the environment, it no longer needs to communicate with the management plane. So it works very well in detailed environments to where this device may be provisioned, touching a network, and then it goes away, which is absolutely the most complicated use case for air-gapped. It's really simple to deploy air-gapped if it never touches the internet or it touches the management plane. But if it touches the management plane, how do you have that smooth break? And then how do you re-reconcile that device when it rejoins the network? So we look at what the device looked like when it left. And one of those ways that we can compare it is by looking at the software bill of materials, the SBOM of the device, to ensure that when the device comes back, it had the same payload of software as when it left. So we can make sure there's not any additional vulnerabilities on these devices.
Thank you. If we can move into roles and RBAC.
Within the platform, which was designed to be a multi-tenant SaaS offering from the commercial side, we've picked up that same piece of software and built a FedRAMP moderate environment. We also allow clients to take this same software and host it themselves. So it can either sit within what we call an enterprise cluster, which is a Kubernetes cluster that we lifecycle ourselves, or it can ride on top of an existing Kubernetes cluster. Palette Vertex is just a Kubernetes application. So that allows us to take the same software and deploy it air-gapped. It works exactly the same. So very tightly integrated is the concept of roles and role-based access control, and then authentication. So you can come into the platform a multitude of ways, via OIDC or SAML. We also have a local authority for leveraging logins, email-based. It can also integrate with a lot of tools to bring a second factor. So you can leverage tools like a key cloak to come in with a username, password, maybe a CAC card, or in an air-gapped environment, the popularity of the RSA token is making a major comeback right with those one-way pagers. So we can bring users into the platform and give them very small scope. So maybe just into a single project or tenant admin. And then we can also build in, hard multi-tenancy. So if we look at kind of the spectrum of multi-tenancy within Kubernetes, your hardest form is going to be, one cluster per developer, as an example. The softest form is going to be namespace as a service, the idea that a developer may have rights to deploy into a single namespace, but they'll be able to see other namespaces. They may not be able to deploy in them, but they know that they exist. And what we've done is actually built something somewhere in the middle. So we leverage a tool called virtual clusters, and we call this app mode. What virtual clusters allow us to do is take a very lightweight Kubernetes cluster. It's a single node K3s, and we actually deploy it into a namespace. So you get the advantages of operating a Kubernetes platform at scale. You have the ability to leverage Kubernetes cluster auto scaling to scale up and scale down that cluster. These virtual clusters also adopt what you've put in place for storage and networking for that larger parent cluster. And then we give a virtual cluster to a developer. They get full admin rights on this cluster. It looks and feels like a real Kubernetes cluster, but it has some guardrails. What this allows them to do is very quickly, build app profiles and come into a nice user interface. We're beginning to call this Palette developer experience, and build low-code, no-code applications. So to give you an example, we can come in and create a new app profile, and again versioned. We can come in and decide how we actually want to deploy a service. So we could bring an object store like an S3. We could bring something like a database, or you could bring a Helm chart or manifest. So you bring that Helm and deploy it on top of a database. So maybe you have a web front end built on top of Nginx that interacts with a database. And again, all this can be automated with API. Once you have your application profile, you can then deploy your virtual cluster. So what your virtual cluster looks like is basically a limit on the pod that's running that lightweight K3s, so CPU, memory, and storage. So it gives us that ability to build those guardrails, but then also allow developers to grab a lot of those new technologies from the CNCF, build those curated stacks, build those applications, and test them with minimal impact to other parts of the organization, and most importantly, production, and keep cost under control.
Great. Thank you. We have one more question. What are some examples of the government versions of the public cloud providers where you have been deployed, and at what impact levels?
So we've been deployed, within the public cloud in the AWS GovCloud regions. We've deployed primarily in impact level 4. We have a couple that are leveraging impact level 5 and 6, which are different SCCAs within Amazon. So one of those is provided by AWS Fences. Azure has something very similar called Azure Gates, and those are their top secret regions, secret and top secret regions. So we've also deployed within Azure in their GovCloud. Very shortly, we're going to be deploying within the Oracle GovCloud. Most likely, around impact level 4 and 5 to start, is you have to manage the policy, that SCCA, on your own for Oracle. On-prem, self-hosted, we've deployed air-gapped IL6 into SAP programs.
Thank you. One other thing that I wanted to get into, and I don't think we talked about it, was actually deployment locations and how it's easy to choose between on-prem, cloud, or bare metal.
Absolutely. So within a cluster, we can add a new cluster, and you're actually going to get an AB here. So import an existing cluster would be if you had a Kubernetes cluster within the environment. We can bring that in either as in view-only modes. We can grab analytics, we can grab observability, or we can bring it in as full control. So bring it in, we'll build a cluster profile based on what was deployed on it, and we'll give you the tools to lifecycle that cluster. We're deploying a new cluster. We give you the ability to deploy on a multitude of infrastructure. So AWS, Azure, data center stuff. So VMware, Metal as a service. This comes from Canonical. This is a way to orchestrate bare metal using a combination of Pixie booting a device and something for power control. So something like an IPMI or an iDRAC. That allows us to treat a piece of bare metal like a schedulable resource. So it allows us to power on, power off machines, scaled virtual machines, and most importantly, upgrade the machines. So leverage the rolling update that's inherent to Cluster API. We actually developed the Cluster API provider for Moz and gave that back to the community. And then we have the option of deploying edge native. So this is that idea that you take that Kairos operating system, you boot that device. Once it touches the management network, we can deploy a cluster profile onto that edge device. And then we also have the ability to support Nutanix. And Nutanix is our first provider that we're using our new framework, which is called CAPI Manager. What CAPI Manager allows us to do is more rapidly adopt additional pieces of infrastructure. And the nice thing about Cluster API is it really puts the pressure on the infrastructure provider to give us an interface. So within the VMware world, there's CAPV, AWS, there's CAPA, Oracle has Cluster API support. I think to date, there's something like 28 or 30 Cluster API providers, and they're continuing to come online very rapidly. So we give you an example of AWS. We can start a new configuration. We'll call this AWS 02. You have the ability to add tags to it. We can grab our cloud account, and then you get the option of deploying either in AWS using IaaS. So the user of Palette would own the control plane of Kubernetes, or you can leverage something like a managed Kubernetes instance like EKS, where AWS manages that etcd and the control plane for Kubernetes. So for this example, we'll use IaaS. We can come through, look at our cluster profile, looks good. And then we can choose what region we want to deploy into. So we have both regions available for GovCloud. So we can do US East. We select a key pair. This allows us to SSH to the actual nodes that are booted from AMI. And then cluster config. You now have some options to add additional workers. So you can change the geometry of a cluster. So you can have additional worker pools, maybe that are memory optimized or CPU optimized. An example of smaller clusters that might just be used for development. You actually don't need a separate worker pool. So you can remove the worker pool. We can bump this up to maybe 3 nodes and then allow for worker compatibility. So that does, it removes the taint from the control plane. It allows us to co-locate both Kubernetes applications and the traditional services for Kubernetes control plane. And then based on our permissions within AWS, we have our instance types. So we can come in like a general purpose and grab a C5, 2XL, or an M5, 2XL, and then deploy. And we're also going to do checks. So one, we give you, the budget amount of what each one of these nodes cost. Then we're also going to look at the cluster profile, and we're going to look at all the applications that you intend to deploy and all their quotas, limits, ranges, and requests. And if you choose a cluster that's too small, it'll actually give you a warning. It'll tell you that you need additional compute, either on the CPU side or the memory side.
I think that that's often overlooked too, is that warning before you go through the build process that, hey, this doesn't look right, or you're missing some storage that is applying to this type of cluster, or you're missing some RAM or something associated with it, to go back and fix it before you go through deploying it. And again, trying to be as efficient and not wasting time, making sure that things are ready to go before you actually push the button and then deploy to wherever it's going.
Exactly. And especially as you move towards infrastructure as code and automating this, is you may automate the build of a cluster to deploy an application, and that application may never come online. And you might have had a cluster sitting there idle, consuming resources for, 1, 2, 3, 4, 5 days before you realize that it was undersized. So really looking at, one, getting the applications in production very quickly, and two, making sure that we're always cost conscious.
Right. That covers a lot of the features that we can get to within Palette and Vertex. Obviously, the tool is very robust, and there's a lot of different nuances that we can get into. Tommy, is there anything else you want to cover at a high level within the GUI?
I think that covers, the vast majority of it. And I think we can kind of roll to, our additional resources and next steps.
Sure. Oh, great. Okay. Yeah, so thank you, Tommy. That was great. Thank you for taking the time. I know it's a lot to talk about for 45 minutes. Thank you, everyone, for joining. As you can see on the screen, we have some QR codes that can take you to our blog, which you can join and then also participate in. Also, you'll see our solution page that has our QR code where you can get more details on some of the actual resources and documentations on Palette Vertex. Also, you can schedule a one-on-one demo with myself and Tommy or some of our other public sector teams if you want to get into a particular use case or software that you're using and trying to move and deploy to. I don't see any other questions in the chat, so I think unless somebody has something they want to join in before we end. No? Okay. Thank you again, everyone. It was a pleasure to present Spectro Cloud and Palette Vertex to you. If you have any questions, please let us know. Thank you.
Perfect. Thank you.